Today, let's go over another easy question. This is a non-premium question that I just solved by myself a couple minutes ago. This one didn't even take many tries, so it's pretty easy. The constraints are pretty small, so let's go over it. So you're given an integer array called nums, and what you want to do is pop 2 times from the front as many times as you can, as long as the sums are all equal. So, for example, we're going to pop 3 and 2, which is 5 together. Okay, we're going to pop 1 and 4. That's 5 together. Now we only have one element, so we can just return 2 because that's how many pops that were of equal sum that we could get. Here, we're going to return 2 because you're going to pop 1 and 5. That's going to be 6. You're going to pop 3 and 3. That's going to be 6. And then you're going to pop 4 and 1. That's 5. That's not equal to the 6's, right? And so you can just return 2 because that was the most we could get up to this point. Here, there's only 2 elements, so we can just pop 2, groups of 2, 8. There is no conflict because there's no other sum already on the stack, and then we just return 1 because we did go through one turn. So if you know how this works, which is pretty simple, and you perform this operation as many times as you can, unless you either have an unequal sum to whatever the top of the stack was, or you have one element left, then you can just return the turns, right? So if you know that, let's go ahead and code it up. Its turns is 0, and then we're going to create a queue because we want to pop from the front, not the rear, right? Doubly ended linked list. And then again, while, let's say, until it contains fewer than 2 elements, so while length of d is bigger than 1, we know we can pop at least twice because we know that there's at least 2 elements inside of it. So then we can say now 0, this is a sum of the pair group, now plus equals to d dot pop left first time, so popping 3, second time plus equals to d dot pop left, that's the 2. So now our list just looks like 1 4 5. And then now we can say we have to increment turns, right? And then we can say if, let's call this current sums or scene sums. I'm just going to contain the 5 and then the 5. If scene sums is not empty, and if now, which is the current turn sum, is not equal to scene sums -1, then we can just return the turns, right? Because that's not valid. Otherwise, and we don't want to increment this until we validated that this is true, because, for example, if we get here, that's 1, here we get 2, and then here that's not valid, so we don't want to increment turns. We want to return and cut it off, right? So it goes back to the function call instead of incrementing again. Otherwise, we will increment turns because let's say this was 2 instead of 1, then this would have been valid. And then at the end, if we just have one element left and we never return turns, then we can just return turns at the end. So, okay, this is 5 instead of 6. Print now. Oh, okay. Otherwise, we also have to append now, which is going to happen after we calculate this guy plus this guy each turn, or this guy plus this guy. So, okay, why is this not working? If the current sum, scene sums, right, so after we calculate the sums, then we want to ask if scene sums, maybe we append it after. Okay, so it's probably after. Okay, cool. Yep, that's what it was then. Because after we calculate the pair sum, then we ask this instead of appending after. Because if we append the current one after, then, for example, we've already appended 4 and 1 is 5. Okay, then this is going to be valid. No, we don't want to do that. We want to ensure that this is the one we're comparing the current sum to. And then if it's the same, then we can append this for the next turn, right? Because there's only, if even one of them is not equal to the sum of the previous pair, then we can already just return the turns. Anyways, hopefully this made sense. It was a mouthful, but just wanted to show you this question. Thank you for watching and stay tuned for more.